Hi everyone, and welcome to the second tutorial for Phrase TMS. In this video, you're going to learn how to customize a text filter by extracting the translatable strings and separating those from the code. So, let's dive in. Alright, so this is the text file that we're going to work with for this tutorial. If you have followed the full video series, you will find this file familiar. So it's basically a text file where we need to specify what are the strings for translation. So as you can see, we have 10 lines, and let me actually maximize this a little bit. We have 10 lines of code, all of them following a similar pattern. So all of them starting with the set, then the identifier, equal symbol, and the string for translation. And at the very end of each line, we're going to find the comment, okay? So the same happens for line number 1, but the same for line number 2. This is just the identifier, this is the string for translation, and this is just some comment, and the same for all of them. As you can see, we also have some embedded content, alright? So first off, we have some HTML tags in here, like the bold tag, and here we have the closing B tag for bold text in HTML, and we also have some placeholders in this pattern, okay, the similar pattern with the opening curly bracket and the closing curly bracket. So what we are going to do is to go straight to the Phrase TMS tutorial project that we created in the previous tutorial, where we have the JSON file, and we're going to create a new job. For this case, we're going to work with the text filter. So let me just first choose the file and specify strings.txt. And we need to scroll down a little bit, and we will find the TXT. This is the fields that we're going to play with. And again, if you hover your mouse over each of these fields, you're going to find some notes and even some links to the corresponding regexp manual, okay? Again, this is the place where you will find useful information on general examples and more specifically on the TXT import, which is the one that we're going to do right now. For example, you have some examples where this is the line on your source file and the string for translation is actually found here. So to import text between this part and this part, which means between this part and this part, so this is the string for translation, use regexp this one, okay? And the same for different structures. If you are familiar with regular expressions, you will notice that what we need in Phrase TMS is to specify with a look behind, and we know it's a look behind because of the syntax, that before the text for translation, and this is the text for translation, so before we need to have this pattern, okay, which is the ##1 # space. That's the pattern that we have before the text for translation. This is the text for translation, and after the text for translation we have the look ahead, okay? So the look ahead is done with this syntax, the question mark, the equal symbol, and then it needs to be followed by this part, which is basically the space ##z ##. This is just an example, but we're going to work with a similar pattern, okay? So in reality, what we need to check is what we have before the strings for translation. So if the strings for translation are found in here, inside the quotes, what we need to do is what do we have in before, all right? So sometimes, and this can be done also in other tools, we can specify the full part, okay? If that's not possible, or if we have some issues or whatever, we can specify just this part, or maybe just this part, or even just the quote, okay? The larger the look behind is, the more robust your regular expression will be. Now, the problem is that when we are working with look behind and look ahead, we are going to have some technical limitations that we will see later on. For now, let's just first create the translatable text, okay? And the translatable text can be found, and let me actually toggle between the file and phrase. So we are going to need a look behind and a look ahead. And inside we have the text for translation, okay? If we specify a look behind, we're looking to the left of the string for translation. So what do we have before? Well, in reality, we have the hash set and then the round bracket, the dollar symbol, and then the key or the identifier. It's the same for all of them, followed by a space, an equal symbol, and a space. Now, some tricky part here, and then obviously the quote, by the way. Some tricky part here is that when we are working with the look behind, we can't actually use quantifiers or optional characters. We need to use a regular expression with a fixed length. So for example, if we have here some white spaces here and here, imagine that, for example, in here we don't have a space. This would actually be a valid file, all right? But we can't use quantifiers or optional characters in the look behind, unfortunately. Okay, the regex engine does not allow this. So the thing that we need to do is to specify the maximum number of characters that we have. All right, so in this case, the maximum character that we had would be all of this. But if you can identify some risks when it comes to removing some spaces in the source file, where obviously this would not follow the same pattern, because after the equal symbol we would not have the white space. Okay, we need to actually find the minimum in that case. So we start from the maximum and then we start iterating or look through the right and see what's at least the maximum number of characters that we can use. And if we can't use all of those characters, we can simply leave the minimum. Okay, so in this case, every time where a quote is found, it's the first quote that we have in each line. Okay, so if we have this quote, this is the first quote that we have in line number 1. This is the first quote that we have in line number 2, etc. So something that we can do is to add the look behind expression. Okay, and if you are not familiar with this kind of expressions, you can always refer to the corresponding part. Okay, which is, by the way, it's the other way around. So it's this and this. Okay, which makes sense because the equal symbol is actually saying that in this part we need to have this pattern. So preceding the text for translation, we need this part. And if we use the exclamation mark, it means that before this text for translation, we don't have this pattern. Okay, so it's the question mark, the less than, and the equal symbol. All right. But again, you can always refer to this part because for the look behind and for the look ahead, it can be some way tricky. So you can always refer to the original guideline. Okay, this is the syntax for the look behind. Now, what we said is that we need to have a quote before the text for translation. So this is the text for translation, and just before we have the quote. That's at least the minimum that we can have here. Again, if we added all of the white spaces, equal symbol, and then another white space, in case there is any white space that is not appearing in one of the lines, you will get into trouble because that line is not going to be included for translation. Okay, that's the technical limitation that I find here with Phrase TMS, because you need to rely on the look behind expressions. Now for the look ahead, that's no problem because we can simply specify this part. So for example, the quote and then the closing round bracket, that's found at the very end or just after each string for translation. Okay, so all of these characters are found in all of the lines. Now what we need to do is to use the question mark, the equal symbol, because again, this is basically saying that following the text for translation, we need to find this expression here. So it's basically a quote, and now it's a round bracket, a closing round bracket, and that's why we need to escape it with a backslash, because we need to capture a literal closing round bracket. Okay, let me just copy and paste this here in Notepad++. Find next. As you can see, the text for translation is going to be extracted the same way. So this is the text for translation. Find next and find all. So here we can see that exactly this part of text that we can see in yellow is going to be extracted for translation. Now that's okay, so we can move on to the next part. And obviously, depending on the source file that you are working with, you might have a different structure, but you can always play around with the look ahead and with the look behind expression. Just make sure that, as I said before, with the look behind, we can't use quantifiers or we can't use optional characters. In some way, that's limited. Now, for the convert to phrase TMS tags, this is very similar to what we had in the previous tutorial for the JSON file. This is the place where we're going to specify the embedded content or the placeholders. In this file, we have two types of embedded content. One of them is HTML tags that we can see in here, and another pattern is the placeholders in the form of curly bracket for the opening character and curly bracket closing curly bracket for the closing character. Now, it's two different regular expressions, so we are going to separate them with a pipe. The first expression is going to contain anything, so we start off with the less than, because this is just the beginning of any HTML tag. We start off with the less than, and then inside we can have any character that is not the greater than one or more times until we find the greater than. Okay, this is just a very useful way of doing this. All right, so let me just copy and paste this. Find next, and we will see that it's capturing this tag and the corresponding closing tag. If we had any other tag like strong, italic, or lists, whatever, that would also be captured, either if it's the opening or the closing tags. And it works because with the square brackets, we are saying that we are capturing one character at a time. The caret inside the square bracket means not the following character. So we are basically capturing any character that is not this one. So any character that is not the greater than one or more times until we really find the greater than character. Okay, that's for the HTML tags. And then we need to capture this pattern, which is very similar to what we did in the previous tutorial. So we need to escape the curly brackets, and again, make sure that you escape these curly brackets with the backslash, although that's not necessary in Notepad++ and in many other tools. It needs to be escaped in Phrase TMS, otherwise you're going to get an invalid regular expression error message. Inside we can have the usual thing, so the shorthand character class, \w for any letter, any digit, or any underscore, one or more times. Let me actually try this here. So find next, and find next, and we don't have anything else. Okay, so it's capturing the three of them, okay, as you can see here. And again, with the pipe or with the vertical line, we can separate each regular expression that we need to add here to convert to Phrase TMS tags. Now, the context key. This is going to be done the same way as the translatable text. We need to use look ahead or look behind. Now, the context key, as you can see here, it's different to how we handled this with JSON. With JSON, we had the context key, which was the real key, and we also had the context note, which was used as the comment. Something that we can do here, because we only have one field, is what would you prefer? Would you prefer, so for example, for this line, when the linguist is translating, would you prefer them to have homepage title as the key or the identifier, or would you prefer to use the comment, if any, in this line for context? Sometimes, like in this example, we have a comment for each line. So if you have this kind of a structure, it would be better off maybe to add the comment, because that's going to add some more reference to the linguists. But some other times you wouldn't have a comment in the same line, and it's better off to just use the identifier that we have for each line. Both options are okay, and this is going to be totally customizable. Okay, so let's imagine that, for example, in fact, when you are translating, or when the linguist is translating, you're going to see that what you see is what you get. So you will see the preview of this text file, and you're going to easily see while translating if there is any comment or if there is any identifier. Now for this purpose, let's just do the comments, all right? So let's imagine that we have the comments at the very end of each line. So what we need to do here is just to add the pattern that we have for each comment, and then we're going to add the text that is going to be extracted as the comment. In this case, again, we can use the key as the comment or the key as the identifier. Okay, it's up to you. Now inside this group, we're going to add the look behind, because here what we need to extract is this comment, all right, all of these comments. So we need to find a pattern of what we have before the comment, all right? So before the comment, we usually have this, all right? We usually have this, the space, the backslash, forward slash, space, as you can see in all of these cases. Now, something that you can do is, for example, to add the backslash, and then just a space, okay? Because here we always have a space. The thing is that, as I said before, we can't have the optional characters, because in a normal regular expression, we would say that this white space is optional, or we could even have a white space 0 or more times, but with the look behind, we can't use that functionality, unfortunately. So in theory, this is going to do the job. So let me actually check this, find next, and as you can see, it's going to extract the developer comment. In this case, developer comment 1, 2, 3, 4, etc. It will work for any kind of comment as long as what we have before is forward slash, and then a space. Okay, and this is the text that is going to be extracted. All of this is going to be taken as a condition. That's what the look behind is in the end. That's how it's done. If for some reason, and I will not use it here in the context key, but let's just do it all together. So if we wanted to extract the identifiers instead, if you find it more useful, or if you don't have a comment as such in every line, you can do the opposite. So you would need to extract this text, okay, which is basically a set of digits, letters, underscores. We don't have any, one or more times, okay? In the end is letters or digits, okay? We could have any underscore, but we don't have any. So we need to capture in the look behind what we have before the identifier. And before the identifier, we always have this text, okay? So the hash set, and let me actually capture this. We need to keep the question mark, the less than, and the equal symbol, because that's the syntax for the look behind. And then the hash is a literal character. Set, the round bracket needs to be escaped. So this round bracket needs to be taken as a literal character, and that's why the round bracket here is escaped with the backslash. And the same happens with the dollar symbol. The dollar symbol is a special character in regular expressions, so this character needs to be escaped as well. And then this round bracket is just the closing round bracket for the whole look behind expression. Let me actually check this, find next. Okay, as you can see, only the identifier or the key is extracted. So if you wanted to use the identifier instead of the comment, you could use this regular expression in here, okay, instead of the comment that we have done here. It would work the same way. Now we're going to use this expression just to extract the comment, and let's just create, so we uploaded the strings.txt file. Let's create the job for this project. We can see here strings.txt, this is the second job, so we can open the file. And now in the Phrase TMS editor, you will be able to see all of the text that has been imported. All right, so originally we had all of this text. So for each line we had this part, the second line this part, and we have been able to properly extract it what we need to translate. All right, so instead of also including the set, header, homepage title, etc., we have the clean translation units. All right, and as we can see, we scroll down, we go until sign in, which is the very last string that we can find in the file. Here, as usual, we have in blue, we have the tags that we have imported. So the B tag, and then the closing B tag is found here. That has been selected or extracted or protected with the regular expression that we used for HTML tags, and the number 2 is the student level, which is the other pattern that we use. So as you can see, using the pipeline in the regular expression for the Phrase TMS tags did the job. Now, something that you can see is that, alright, so the text for translation here in the preview tab is found in gray, and any other text in black is not imported for translation, okay? And then in the context node, if we click on the first translation unit, you will see that the key is developer comment 1, because the key for this string has been extracted as the comment, okay? Remember that we had two possibilities to extract this part or the comment as such. So we extracted the comment. If we click on courses, for instance, we can see that the key is developer comment 6, because for courses we have developer comment 6. Again, if we had used this other regular expression, you will have seen that the context key that we have here should have been menu 1 instead of developer comment 6. So as you can see, it's totally customizable. So that's really it. We have seen how to create a text filter, looking at the structure of the text file, identify where is the text for translation. We have used the look behind and the look ahead. We have seen also the limitations that we have for the look behind, because sometimes if we need to use a quantifier or an optional character, that cannot be done with a look behind, unfortunately, and that's the way it works with Phrase TMS. And lastly, we have seen how to import the embedded content, both HTML tags and this other pattern, and how to also use the developer comments as the key, in this case the context key, for reference when the linguist is translating. And that's all. I hope you have learned some good tricks when preparing text files for translation using Phrase TMS. In the next tutorial, which is the third and last tutorial for this tool, you're going to learn how to run a pseudo translation and how to export the translated files, making sure that your parsers are correct. So stay tuned and see you in the next video. Bye!